move my chair.
Get in position.
Right here. I won't be far behind.
All right. So we're just going to get started in Unity. This is the game engine that we're using. So we'll start a new project. I'll just call it Hour of Code. All right. So the great thing about Unity, you have the 2D and 3D option. We're doing a 3D project. But the great thing with Unity is that it also comes with a physics engine. So it runs along in Unity. And physics is super important. That's what we're going to be manipulating a lot with the code to get the objects to move. Okay. So this is your basic startup screen for Unity. So this is your game world scene. This is where you're going to see your objects, your creatures, your characters, all that kind of stuff is going to be in here. The next big important area of Unity is this called the hierarchy. This is where all of your game objects exist. So everything inside of here, all your objects, no matter if it's a creature or a character, it's a game object. Okay? So then over on the opposite side in the inspector, when you have a game object, this is where all of your properties of that object are going to be listed so you can see exactly what's attached to it. Also down here on the bottom is your project. You'll see your files, your folders, all that kind of stuff. And this console. This console will be important later on for coding. Okay, this is where you're going to get any compiling errors. This is going to be your life and death of you. If this comes up clear, you're going to have the best feeling in the world. Otherwise, you're going to get errors and nothing's going to play. So this is very important later on. So to get started, like we said, we're going to drag in a plane. This is going to be our ground. So we use a 3D object and we'll go to plane and it just pops in. Okay, and over on the side, you'll see these are its components, okay, that are attached to this game object. So the most important thing with all game objects is that every game object has this transform, okay? So transform has three big essential parts to it: position, rotation, and scale. And this is what you're going to be manipulating a lot with your coding. Okay, to demonstrate the transform, I'm just going to drop in a cube real quick. And there's the cube. So position here in the X, because it's a 3D game object, you have your X, Y, and your Z. So height, width, and depth. So your X, you can come over here. You can adjust the value and move the cube. You can also use it up and down and in the Z direction to get it to move. Rotation works the same way. You can get it to rotate different areas. Okay, and your Z. And the scale is the same. So if you want to adjust any of its widths, height, or depth, it's just that simple to make it move. Okay. So, and also there's arrows inside here. You can adjust things just as easy in the game scene. Okay. So we'll get rid of that guy, and the next thing we're going to bring in, what we're going to use to move is going to be a sphere. Okay. So as you can see, we have our sphere. So over here in the inspector, again, the sphere has the transform. Every game object has it. This also comes with a sphere mesh filter, a sphere collider, a mesh renderer, and then a material object. Okay, that's what's all attached to this ball. So if we just leave everything how it is right now and we hit play, we'll see what it looks like. Okay, so right now the camera is positioned. You have the plane and you have the sphere, but nothing's happening at all. Why is that? Because the sphere doesn't have anything attached to it that's using the physics component of the Unity engine. So what we have to do is add a component to this sphere so to be able to get it to move with physics. So we come over here, add component, physics, and we're going to give it a rigid body. So the rigid body is what gives this sphere mass, drag, angular drag, if it uses gravity or not, all these different things, which is what we need to manipulate in order to get the ball to roll along this plane. Okay, so now that it has some mass, okay, and it's using gravity, we'll hit play again and see what happens. And it falls. It has the mass, it's using the physics component to drag it down based on gravity. However, it falls straight through the plane. Okay, that is not what we want. And the reason why it does that is because now this plane, it has nothing attached to it that's using the physics. So we have to go to the plane itself and add a physics component to it as well. But because we're not wanting to move the plane in any direction or use gravity or manipulate its mass or anything like that, we simply just need it to be a ground. The physics component that we're going to use for it is going to be a mesh collider. Now, if you remember on the sphere, this has a sphere collider on it. So the goal is now that both of them have colliders, that when the ball drops, the colliders are going to connect and be able to detect when they're hitting each other, and it'll stop the sphere from going through the plane based on physics. So we'll hit play. And there you go. So now it can detect itself, and now the ball can just roll on the plane. Okay, but in order to get it to roll, that's where it comes in coding. Okay, but before we do that, we're going to assign a material real quick just so that we can better see these objects. So we're going to come down, we're going to create a new material. Okay, and we'll label this one just ball. And let's do a bright red. Okay, then you simply just drag the material onto the ball, and there you have it. So we'll do one more. Create material, and this will be the plane. Okay, and we'll just do this one a darker color so you can see. And drag it onto the plane. Okay, so there you have it. So it's a little bit easier to see now. So now we can detect all the different movements. So from here, that's just a simple game setup, just the plane, the sphere, it's got its components so it can work with the physics components, which is what we need to now manipulate into coding. So I'm gonna hand it over to Eric, and he's gonna start typing because I'm not as fast of a typer as he is.
So we're gonna trade positions here. Thank you, Haley.
Of course.
Thank you. And now we're gonna start writing some C# code, and I noticed there's an area here that you're going to need to see, so I'm going to just move this little window over. So my face is the least important thing about this whole shenanigan, so you don't necessarily need to see that. All right, so let's go ahead and write a little bit of code that's going to get this ball moving. Like I said, the end goal is that we're just going to hit the up arrow. It's going to add some force to it to get it to kind of start rolling, left and right, down, all that kind of stuff. But first thing I want to do is I just want to manipulate our camera. So you were talking about the transform. So I'm going to click on my main camera object because right now we have this, like, you can see down here in the corner, it's kind of like this awkward side view. So I'm just going to kind of rotate this camera down a little bit and pull it up so I can kind of see the whole thing better. There we go. That's totally fine. All right, it is time to script. So to begin a new script, what we're going to do is we're going to right-click and we're going to do create a new C# script. I'm just going to call this a movement controls. Now, what is a script? A script basically is a file that contains code. Best practice when you start getting into programming, you want to have as many scripts as possible. You don't want one file with 20,000 lines of code on it. You want to break it up into little small pieces. So this script that we're going to write is going to just control the movement of the ball. So here's where we're going to actually start writing that code. We're going to double click on the script, and this is going to launch MonoDevelop, IDE. What's IDE stand for? Integrated Development Environment. Yeah. And ta-da! And what I'm going to do, I can't remember how I did it. Oh, there we go. Hopefully that will be bigger for you guys to see. I know it might be kind of hard looking at the Unity thing. It might be blurry, so hopefully you'll be able to see this. So this is that white screen that we've been talking about this entire time. This is the screen of infinite possibility. Yes. Anything can happen. Whatever you have, the dreams in your head, this is where you make it happen. So real quick, just kind of seeing what you see here. Just ignore those for now. That's kind of beyond what you need to know. You can kind of see the movement control. That's the name of the file that I have there has been moved in. And then there are two things that you do need to understand. So this piece of code right here, void start parenthesis, and then you have this like open bracket, close bracket. That's called a function. And in Unity, this is called the start function. What the start function means is that when the game starts, it's going to run whatever code is inside of here. And so the code lives in between these brackets. So whatever I type in here, that's going to run one time and only at the start of the game. And then that code's never going to get run again. The difference then, we have another function down here called void update. So the update function inside of Unity, this is running code in here every single frame. So that means like if you know, most games run usually anywhere from 30 frames a second to 60 frames a second. So it means that whatever code is inside of this void update is going to be called 30 or 60 times every second. So there are some advantages to why you'd want to do that. And that's where we're going to start writing this code. So inside of this method, so in the void update, inside of these nice little curly brackets, every frame is going to come down and check this kind of stuff here. So, and just by the way, cast kicks.
Good job.
Yes, integrated development environment. I just saw the chat. They knew what it was. It's fantastic. So the first, one of the most common elements in programming is what's called an if statement. So an if statement is written like this, and then I'll explain what this means here in a bit. And the nice thing about an if statement, it sounds exactly like the way you'd expect it to work. Basically what you're telling the computer is, if so-and-so is true or is equal to a number, run the code inside of me. If it's not, then ignore me. That's essentially what this if statement means. So basically any code that I type in here inside of this if statement is only going to be run if whatever I tell it is true or whatever. And where we give it that kind of statement or function is inside of these parentheses. So it says if, and what we want to do is we want to write a piece of code that says if the person hits the up arrow key, then do this. So we're going to write code that says that. So we're going to say if, and this is how you would write it. You do if input dot get key down. Okay. So basically we're saying if, and it's going to look for an input, and it's looking for the get key down. So every time you press a button, you tap. There's all these different things called states. When you tap it, are you holding it? When you let it go? So this is what we specifically want when the computer notices that a key is going to get pressed. Now we got to tell it what key for it to be watching. So we're going to do key code dot up arrow. And so essentially we kind of wrote our first line of code. What this says is if, and this is again, remember, happening every up to 30 times a frame. If we hit the up arrow key, get the key down on the up arrow, do this. And a statement that you will commonly use in programming is what's called debugging, or a debug log, or a print function. So you write something like this, debug.log, and inside of here, I'm just going to write pressed up arrow key. What this debug log does is a great way to test your code. Right now, before I even go and do anything else, I want to make sure that my if statement is working before I go and start making this even more complicated. So what I can do is, as soon as I hit the up arrow key, then I should get a little sentence that's going to print in Unity that says pressed up arrow key. And if I see that, that means we're doing good. That means like, whew, okay, the code's working. It's detecting when the up arrow is being hit. We can move on. So let's give it a test.
It's always great to use the debug log, because if you start writing too many lines of code and then something doesn't work, it could be anywhere in that code that something could be broken, and you don't know where. So this, you just take it little chunk at a time, and you can make sure that you're on the right track.
Yeah, it's best practice. Use debug log or print functions, like whatever language you're going to learn, figure out what that thing is. Yeah. It's so important. All right, so let's jump back into Unity. Now, the first thing we're going to want to look for is down here. There's this console, and do you see how nice and clean that is?
That's how you want
that
it.
means we wrote code that actually is not broken.
Yes.
That's fantastic. Now, this is how sensitive code is. If I go back to our script, and you can see I add this semicolon after the line. Basically, a semicolon in programming is like a period in the English language. Most of the time, you're going to always want a semicolon following your line of code that pretty much tells the computer that you're done. If I just forget that, forgot to put in my semicolon, and I want to come back over here, and you can immediately see, it's kind of, I know it's hard for you to see, but you see these two little red things, and basically it's saying, warning, and it says unexpected symbol. But the common term, it says, I have a parsing error. A parsing error is basically a typo. I've broken something somewhere. So you can just see how by removing one little thing, It can all just break, and it will not let you. So let me actually just remove that one more time. If I wanted to test my scene with this bad code, I cannot. It basically gives me this error that says all compiler errors